Moin, I'm Lars from Technical University of Dresden, and we did a visual search for sounds with the similarity analysis of sketches. We probably all know those folder structures where all the sounds are organized for, let's say, dubbing a movie, hopefully having a meaningful name for all the sound files. In most libraries for dubbing and also for synthesizer and sampler, luckily, all the things are tagged and classified so that we also can use a query by text or searching by tag. Another method would be to represent all the sounds with a visual counterpart so that it is easier to explore a huge library. Additionally, there are other querying methods. With query by example, you can put in an existing sound to get similar results. But for query by example, you will always need this very example. If you just have a sound in mind, you need something else. Well known is also query by humming, singing, maybe more suited for melodies and songs, but also tapping or beatboxing for searching for a specific drum loop. Using these techniques for using a, let's say, synthesizer sound or a real-world sound, so you try to vocalize the sound you want to find. There are also other things like in the visual domain, the query by visual example, and also the query by sketch, or actually putting a sketch in and get a corresponding image out. We are looking a bit deeper into query by sketch here. Therefore, we conducted an online user elicitation study where the participants had to draw their impressions. We choose 30 samples across different real-world instruments and more abstract synthesizer, as well as real-world cracks and noises and artificial banks, to somehow guarantee a good mixture between where it's clear what the generator is and also more abstract synthesized sounds. The participants had only 30 seconds per sample, so that they really drew the first impression and not are able to redo something. As the participants used their own hardware in this online user elicitation study, no sounds had information in the very low end nor in the high frequencies. Also, the participants had to perform a hearing threshold pre-test so that we can ensure that everything was audible with their hardware at home. "30 invited participants took part with a good range of different knowledge. With 30 sounds tested, this results in 900 sketches. Also, the hearing threshold follows the standard curve, although for some participants, the lowest and the highest bark band was not audible as assumed. We do not limit the participants and the hardware they should use. Let's go quickly over all the sounds with the corresponding sketches. In the recited sketches, there will always be different types of sketch classes, like the curve the sound is doing, or an impression of the sound itself, or a try to somehow sketch the generator of what could have produced the sound. The more abstract a sound is, let's say the more abstract the sketches, so the more the participants tried to really draw the curve or the impression. The more real-world a sound is, the more the participants try to somehow, in this case, through maybe a keyboard or the generator. For a sample where it's clearly audible that a crowd is talking, participants still drew abstract impressions of what they heard. The easier the sound is depictable and the easier effectively the generator is drawable, the more the participants tends to draw the symbol here. Although there are still people left to draw the curve or the waveform. The interesting thing here is that the stereo sound only has information in the left channel. Some of the participants tried to express that by trying to sketch a person whistling from left in the ear, or by having a line only on the left side of the sketch. As we did not use the sketches containing text or being empty, we are reciting in 855 sketches. To ensure a proper training, we augmented our dataset by introducing some distortions, because not every sketch is perfect and you will always jitter if you try to reproduce a sketch. And also left-to-right mirroring. We did not include top-to-bottom mirroring, as most of the sketches had a meaning and where the horizon is. By having 10 different distortions and different mirrorings, we result in 8,550 sketches. Learning the correlation could mean that we somehow represent our sketches and the corresponding audio data in their own feature representation, and then trying to learn the correlation between them. A bit advanced is to use a multimodal autoencoder, where you can put in different modalities to train a shared representation. Here, feature extraction means that we put in the sketch as a pixel representation and the audio input as a MFCC representation. By training the autoencoder, so the encoding and decoding, it is possible to put in a new sketch, encoding it, and then decoding the sketch to audio, or also put in a audio file and to get out a sketch representation which could describe the input. But as we only have a very tiny sparse dataset, this is very noisy to decode, so the decoder has only been used for training the encoding part. Because querying this multimodal autoencoder is performed by putting in a new sketch, performing an encoding, and then doing a k-nearest neighbor of all known audio files, which also have a vector in this latent space. Additionally to the multimodal autoencoder, we trained also a sketch-only autoencoder, and where we can also perform a k-nearest neighbor search in the latent space, and then to put out as a recommendation the associated audio files with those result sketches. To sum it up, the learning did well, although it was a very small, sparse audio set. And although after 20,000 epochs, there's still noise in the decoder part. The sketch-only autoencoder performs well in expressing the squiggly lines, zigzag things, or upwards trends, but we did not perform the user test yet to ensure the meaningful recommendations from this model. The model from the multimodal autoencoder is a bit more under stress, and the main issue with the multimodal autoencoder is that we do need always to put in all the modalities as a query. But as we only have the sketch, we have a missing auditory part for the input for this model. So there are different approaches, like having just zeros in it, so having no sound, or having somewhat of a white noise. So this is why the model nearly all the time outputs the laser gun blast as a good recommendation, because this sound is very short, so has a huge zero padding at the end. So here the silentness of the sound itself. A proper solution could be here, encoding it to latent space and decoding the auditory part again, having a very noisy representation of audio, put in again with the original sketch and the new audio, and there are several iterations like a Griffin limb algorithm. Another fix could also be to use both models, so having the sketch-only model first, having associated audio files. Interesting would be also whether these models are suitable to tackle the cold start problem, for instance in online gamified studies. Also, we did not look into different models for each sketch class, because every participant had their own visual style. Maybe personalized models would be best. Thanks and have a nice day.